Hello grade 8s and welcome to lesson 3.5 on applying the Pythagorean relationship. In this lesson you'll be using your knowledge of how to solve right triangles using the Pythagorean relationship to solve problems that involve right triangles. In each problem you should try to make a diagram in which there will be a right triangle and label all the side lengths that you know in that right triangle, and then try to find the missing side length before you go on to answer the problem. So for instance, in example 1, we are given a staircase of 12 steps, each step with a rise of 7 inches and an 11-inch tread. And suppose you wanted to make a handrail, how long should it be? So here's the handrail, here are the 12 steps, you can see the 11-inch tread and the 7-inch rise. And one thing I should point out to you is that I've decided to make a handrail here, which is maybe a little bit longer than you were thinking initially. Maybe you were thinking that horizontally it should only be 12 times 11 inches long, and as far as the vertical component only needs to be 12 times 7 inches high. But what I've decided to do, you can take a look at this handrail, you can see that it extends a little bit further beyond, and the reason for that is safety, really. I've done this so that when you get up to that top step, when you get up to this top step, you'll still have a handrail to hold on to as you pull yourself up to that level. And even as you get down to the bottom of the staircase, you'll still have that handrail to steady yourself. And I think that's a good safety feature for this handrail. So that means that really, when I look at the horizontal component and the vertical component, it's going to be maybe a little bit longer than you were expecting. Let's take a look at this. So first of all, I'm going to complete this right triangle here, and I'm going to identify that right here is where we have our right angle, and I'm going to do some calculations to figure out the side lengths. First of all, vertically, what we could see again was that for this handrail, it's not 12 times 7 inches, but it's actually, it goes a little bit beyond that. It's actually 13 times the 7 inches. I've done that so that there's that extra little bit at the top and at the bottom. So 13 times 7 inches is the vertical component to this handrail. And 13 times 7, I can use my calculator to work that out. 13 times 7 is equal to 91. So it goes up 91 inches. Secondly, if we look at the horizontal component from here to there, it is also 13 times 11 inches, and this works out to be 13 times 11 is equal to 143. So it is 143 inches in length that way. Again, if you take the handrail and you move down onto the staircase, you can see that. You can see that I've made it long enough to extend a little bit further beyond at the top end and at the bottom end, so that for safety, when you get to the top of the stairs, when you get to the bottom of the stairs, you still have something to hold on to steady yourself. Okay, so now that we know the lengths of the legs of this right triangle, we can figure out what the hypotenuse is, and of course the hypotenuse is the length of the handrail. So what I'm going to do is I'm going to do 91 squared plus 143 squared. That's like a squared plus b squared. And that will be equal to c squared, which is the hypotenuse, that's the rail length. Since I want to calculate the rail length, I'm going to need to take the square root of this result. So let's see what I get. And I'm going to round this off to the nearest 1/10 of an inch. So it is the square root of 91 squared plus 143 squared, and that's equal to 169.5 inches. Now, if I divide that by 12, this will tell me how many feet I have. Okay, so there's 14 feet, right? And 14 feet, 14 times 12, there's 12 inches in every feet. That's 168. So really the 169.5 is 14 feet, 1.5 inches. Okay, this is much more convenient to use if you go to a store that sells lumber or that sells handrails, and you're asking for a length. Most likely you're going to be working in feet and inches, not just in straight inches, especially when you get into a length that's that long. So here's one application where it makes sense to use the Pythagorean relationship. Okay, so here's my final answer. Put that in the box. Let's take a look at another example where we can use the Pythagorean relationship to solve a problem. In example 2, it says Johnny and Jamie are racing from one corner of a soccer field to the opposite corner. You can see here's the start and here's the finish. The dimensions of the field are 100 meters by 60 meters. You've got Johnny, who runs at 10 meters per second along the perimeter of the field. So Johnny is taking this route that I'm highlighting in yellow. And he's going to make a 90-degree turn right there. Okay, that's the perimeter of the field. Now, on the other hand, you have Jimmy, who doesn't run as fast, but of course he takes a shortcut. He goes along the diagonal of the field to get to the finish line, and so that's going directly from the start to the finish, and this is a little bit of a shortcut. Of course he doesn't run as fast, so it's kind of hard to tell who's going to win this race. Let's see if we can figure out who finishes first and what is the margin of victory. So Johnny's time in doing his run, what we do is we take the total distance, which is 60 meters plus another 100, and we divide by his speed, which is 10 meters per second. Okay. By the way, if you're not sure about the whole relationship between distance, speed, and time, here's a really quick way to remember. Distance is equal to speed times time. Right? If you'd like to know speed, you're doing distance over time. Okay. If you would like to know what is the time that it takes to do a certain distance at a certain speed, it's distance over speed. So that's where I'm getting this total distance of 160 meters and dividing it by the speed of 10 meters per second. So that's a nice little memory aid to help you to remember the relationship between distance, speed, and time. And you can keep that in your notes if you like. Just gonna take that out to save a little bit of space here. So again, Johnny is running 160 meters, running at 10 meters per second, so it is going to take him 16 seconds to run his part of the race. Jimmy, on the other hand, is going to go not quite as far. The distance, which is along the hypotenuse, is going to be 60 squared plus 100 squared, and we have to take the square root of that. So we're finding the length of the hypotenuse there, and we're dividing by his speed, which is 8 meters per second. So let's see how long it takes Jimmy. So the square root of 60 squared plus 100 squared divided by 8 is equal to approximately 14.58 seconds. So it takes Johnny 16 seconds, and Jimmy, it only takes him 14.58 seconds. So it looks like the winner is going to be Jimmy. And now the question is just, what is the margin of victory? So Jimmy finishes first by, and now we just do 16 minus 14.58 to find out the margin of victory. So 16 minus that answer that I got in the previous line is 1.42 seconds. Now these are just two problems that you can solve using the Pythagorean relationship, but of course there are many more. So I would encourage you to do all of your assignment questions. Again, in each case, make a diagram. It should have a right triangle in it. Make sure that you label the sides that you know, solve for the missing side length, and then answer the problem. Thank you for watching this lesson.